In today's project, we're going to be installing a manual transfer switch connected to our home's electrical breaker panel. The manual transfer switch is used in combination with a generator and is going to allow us to supply electrical current in case of a power failure to chosen circuits within the panel. During the video, I'm going to be highlighting the steps that we're taking, the materials and tools that are needed. Follow along. I want to take some time to speak about today's video sponsor, Reliance Controls. Since 1909, Reliance Controls Corporation has specialized in manufacturing a wide variety of electrical products. USA-based Reliance is the leader in portable standby power integration. They have been awarded over 88 patents on their devices. After over a century, they have built an outstanding reputation for the highest quality and exceptional customer service. My dealings and communication with Reliance have only accomplished to confirm what was previously said. Their outstanding service, coupled by their friendly staff, really helps them stand out as a true leader. Special thanks goes out to Chris Flagel, Director of Sales and Marketing, for his exceptional and friendly service. A link to their website, as well as a list of all components used in this video, are in the description below. The following illustration details how a manual transfer switch is wired to the main breaker panel. Here, we see our circuit with the light bulb. Its black hot lead is being interrupted by the transfer switch. The red wire from the transfer switch is brought over and connected to the circuit breaker that would typically occupy the hot lead from the light bulb. Connected this way, the transfer switch acts as a middleman or decision maker within our circuit. On the transfer switch, we have toggle switches that can select for each circuit. We have the option for city power. There is an off setting to prevent any electrical current to flow to the power device. And thirdly, a generator setting that would allow our generator to power the light bulb. The main advantage of the transfer switch is that we never have to worry that once city power is restored, that we would have both city power and generator power flowing to our powered device. We must make the decision and manually switch from one power source to the other. I am not a licensed electrician, and anything you see in this video is for entertainment purposes only. With the transfer switch in hand, we're going to have to find a place to mount it and secure it. We're going to want to put it as close as possible to the main panel. Now, Reliance is generous in the amount of wire they give us, roughly 48 inches. But we do have to keep in mind that these leads not only have to enter the main panel, but they're going to have to be routed to the particular circuits that we're going to be powering. Let's also be mindful of how we mount it. We're going to want it to be secure. It's not light, so it needs to be adequately secured either to a stud or to a backing panel that will be adequate enough to support the weight of the unit. In my scenario, I do have a nice place here right beside the breaker panel. That's where I'll be mounting mine. For the armored cable, depending on how close your transfer switch is to your main panel, you're going to have to cut it to length. Reliance gives us a good length of it. In my case, I marked exactly where I have to cut, which will be here. Let's do that now. The armored housing can easily be cut with a hacksaw. In order to prep everything, we got to put the metal armature over all the loose cables. So you're going to start at the end and you're going to feed these cables through the armature. And take your time, get them all in. They will all fit. You might have to play around with it, but they will go. Definitely take your time on this step as not to damage any of the insulation on the wires. Also make sure that the end bushing in the armature is well placed. Once you have the metal sleeve all the way up, you're going to take the provided end cap and the two Phillips head screws. If you look on the end cap, there's a little tang that fits into a slot over here. We're going to put that in and we're going to squeeze and insert the two screws. And now we are secured and our armature in place. I want to make one note for you guys, depending on what side of your breaker panel you're going to be putting the transfer switch. This metal elbow that you see here can be repositioned. If you open up the panel on the inside, you have a thumb screw a nut that you will loosen, and you could then orient this 90-degree elbow in any way you feel best fits. When choosing on the height of the transfer switch, we want to take into consideration where our knockouts are on our panel. Knockouts are the tabs of metal that get pushed out to receive a collar for the wiring harness to go into the panel. So we look at our line, we know which knockout we want. You're going to go from the outside with a screwdriver and a hammer, and we're going to knock inwards on that quarter size tab of metal, pushing it in. Remember, when working around the panel, I think it goes without saying, make sure the power's off. The cable connector you see me installing here is provided in the kit. You will then insert your armature and tighten the clamping screw. Now the transfer switch is mounted on the wall and our wires are run into the main panel, we're going to have to select which circuits we're going to want to power with the generator. So go through your panel if you haven't already. It's always great to identify your circuits so you know exactly what goes where. For this particular transfer switch, we have 6 available slots, and with this particular transfer switch, 120 volt circuits only. So no 240 circuits like water heaters, stoves, dryers. So I went ahead and I identified my 6 circuits that I want to power, and I identified them with green tape. Now we're going to go into detail on how to wire them up. For this purpose, we're going to do one of the circuits together. So from the transfer switch, we're going to isolate and identify the red and the black wire that we're going to need for that circuit. I've identified that as circuit A. And if we look in the transfer switch, our individual circuits are lettered in the same way, A through F. So A will be my first one. Now, looking at the wires, both the red and the black will have identifications on them printed onto the insulation of the wire. You'll have to look very closely because the printing is small, but you will see the letter A printed along the insulating jacket of each of the wires. So in this case, I've identified both A's, black and red. As you saw earlier in my diagram, black is going to be connecting to the black wire coming from our device. So in this case, I'll be disconnecting the black wire from breaker number 1, identified as A, and with a wire nut, tying this black and that black together. And the red wire from the transfer switch will be brought around and put into the breaker. So let's do that now. Once again, I can't stress the importance of turning off the main panel and ensuring there's no electrical flow into the breaker panel. As this connection is the combination of a stranded and solid wire, they do not need to be pre-twisted. Always ensure you're using the proper sized wire nut. In addition to wiring up the individual circuits with the red and black wire, there are 2 other wires that we need to connect from the transfer switch into our main panel, and that'll be the white neutral wire and the green ground wire. The white neutral wire will go to our neutral bus, and the ground will go to the ground bus, and you'll see that in your panel. In my case, my ground bus is right here. All the exposed copper leads go into it, and my neutral bus is on the left-hand side as well as the right-hand side, and all my white go into those. So let's go wire that up now. When routing your wires into the panel, always ensure to leave a little bit of slack so that the wires are not overstretched. With the transfer switch installed and our corresponding circuits all connected, the next step we're going to need to do is run our power cord to our power inlet box. The power inlet box is here. In this case, because it's a 120 volt system, it's an L530. So L5 for 120 volt, 30 for 30 amp. It's a 3-prong. So the power inlet box can be installed either indoors or outdoors. But obviously for the purpose of a generator, it's going to be best to have it on the outside of the house. I will be running it through my garage to the back of the home. This way when the generator is running, it's out of sight from people on the street. To get the power inlet box out to the outside of my garage, the cable we're going to be using is a 10-2 cable. 10 signifies the gauge of the wire, a 10 gauge wire, which is what is required for a 30 amp system under a 25-foot run. I have a 22-foot run from the transfer switch to where the power inlet box will be. In my case, I'm using an armored shielded cable that I will be running. With a Phillips screwdriver, remove the 2 Phillips screws from the transfer switch. This will remove the front panel. With the panel off, it will expose the 3 connectors you will be connecting to: your black hot, white neutral, and green ground. You will then remove one of the knockouts within the transfer switch casing. At that point, putting in a wire connector, once again not provided with the kit. Then you will pass your wire through and secure it with the screw. With our wire that's going to go to our power inlet box fed into the transfer switch, we're now going to connect those wires to the wires within the transfer switch. This step is pretty straightforward. It's going to be black to black, white to white, and bare copper of our inlet wire to the green wire of the transfer switch. So let's go ahead and do that now. With our connections made, we can then put the front panel back on, securing the 2 Phillips screws. So here we have the armored cable coming in behind, following the exterior wall of the garage. And the exit point is going to be right here beside the door. I'll show you now exactly where it'll be on the outside. This is Quebec. Welcome to winter for all those of you that are not used to snow. And this will be where the power inlet box will be mounted. So it'll be a straight shot for the wire. So let's go ahead and install that. In preparation for the wiring, the inlet box does give us multiple locations to run our wire. We will remove the front panel and remove the appropriate knockout plate. We will then put our wire connector in place, once again not supplied with the kit. We can now go ahead and make our wire connections. Our bare copper wire will go to the green screw. Our white wire will go to the silver or nickel plated screw, and our black wire will go to the darker brass colored screw. We can now go and secure the cover back in place. The following are some photos of the finished installation. Here we could see the power inlet box fully installed on the outside of the house. And now the generator plugged in and powering the manual transfer switch. I went through and tested each circuit, and everything performed as expected. Well, there you have it. The install of the Reliance manual transfer switch into my home's breaker panel. In full transparency and honesty, this was a partnership on the video with myself and Reliance Controls. Everything you saw me install here today was sent to me for free. The only thing I had to purchase was the 10-2 armored cable. That said, even though it was a partnership, in my talks with Reliance, both myself and them stressed they want full honesty, full transparency in the install, and to point out anything that I may find is difficult or could be done better. They want to hear real world application and see how homeowners are doing the installs, and to be able to see also maybe where improvements can be made. If you have a simple understanding of electricity and you're feeling comfortable to do this, it is an easy install. Of course, check your local bylaws and local codes to make sure you're respecting those. And if at any time you're not feeling comfortable, hire an electrician. Now, with that said, what about some of the critiques I may have on these Reliance transfer switches? For myself, there was one, and that's mainly because of the way my install is set up. the length of wire or cable that comes out of the transfer switch, notably the red and black wires that feed the individual circuits. They're 48 inches long, 4 feet, and that may sound like a lot, and it is. But in my particular install, I was short a little bit. The reason being, in my install, the transfer switch sits a bit lower on the right-hand side of the main breaker panel. The majority of the circuits I was feeding were on the left-hand side, down low. Because of the placement of my breaker panel, I was obligated to bring my wiring up, over, and down. And because of that, I was about a foot short on some of the circuits for the wiring. Luckily, I had flexibility within my panel. I was able to rearrange the breakers and bring the ones I needed to back up with the transfer switch higher up on that side to be able to reach the wiring. But if you don't have that flexibility, that might be a negative for you and might hinder you from doing the install. So an advice I would give to Reliance controls, maybe give an extra foot or two on those wires to accommodate these kind of installs. And that's it, guys. If you have questions or comments, definitely leave them down below. I'd be more than happy to respond to them. My email as well is always in the description. Feel free to reach out to me. And all the parts and items you saw me install in this video will be listed down in the description. This particular install, as I noted, was a 120 volt install, so 15 to 20 amp circuits. Reliance does have a wide variety of products to meet your needs. They also have transfer switches that could feed 240 volt. So if you want to power heaters, dryers, stoves, water heaters, etc. I definitely would recommend going on their website and seeing the kind of products they have. So thanks a lot, guys, and thanks a lot to Reliance Controls for having the confidence in my YouTube channel to demonstrate this install and to be honest as well. Thanks a lot for watching. I'm going to see you in the next video.